In the second half of section 5.2, we're going to take a look at the same type of trinomials of the pattern x squared x no x. The big difference being, notice there's an a now. It's saying a not equal to 1. This requires us to do an entirely different approach than what I was calling the easy case number game in our last video. The approach we're going to use still involves the number game, but the way we utilize those numbers is different. So this method has the name of bottoms up. I did not come up with that name. I kind of wish I did. But bottoms up is a method that we're going to use to attempt to factor trinomials of this form. So the process is here. I'm going to basically walk through it as we go, just so you can see what these really mean. Notice again, first step is always, if possible, factor out a GCF. That's, as we said, first step GCF, always and forever. So the next step, after looking for a GCF, we're going to find two factors, two integers, p and q. So here comes the number game, but slightly different. The difference of this number game is right here. Notice it is not two numbers that multiply to c. It's two numbers that multiply to what you get when you multiply a and c. So that is in a sense, that's the first step. That's what I will kind of call the first step of the problem, is determining what that is. What is a times c? And then looking for pairs of factors to that number that also add to b. So that's the number game. Two numbers that multiply to something and add to another. It's just that something is a little different than it was in our easy case number game. So let's do that first. Just this process for our first example. So with our trinomial, we see the k squared k no k. We've got something other than a 1 out front. And if we try our first step GCF to see if that resolves it, 6, 19, and 10 have nothing in common. So that did not help us. But now, here's where, as soon as this thing here is not a 1, right, we're not in the easy case. So what I do first is off to the side, pretty much again, all side work. I take 6 times 10, a times c. So that gives me 60. And that gives me the number that I want to look at factors of, just like we were doing in the other number game process. So this one's got quite a few. 1 and 60, I go to 2, and 2 works, 2 and 30. I'll try 3, and 3 works, 3 and 20. I'll try 4, 4 works, 4 and 15. 5 even works, 5 and 12. 6, 6 and 10. So these are all factors of 60, right? All pairs. Now, 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we get to 10, so we're done. So, rather large list of numbers that multiply to 60, right? Numbers that multiply to the AC. Now we want those same two numbers to add to B. Well, B is a negative 19, so that should tell you that if you're multiplying to a positive but adding to a negative, we're really considering these as both negative number pairs. And to find the pair that adds to a 19, specifically a negative 19, would be negative 4 and negative 15. Now, the big difference. These don't just jump into some binomials and give us our final answer. That wouldn't work and wouldn't make sense. Now, what we are going to do with these doesn't make sense. You're going to look at this process and say, I don't know why we just did what we did. And the answer is because it works. I'm not going to bother trying to explain how this process actually, why it works. Just, it's a step-by-step process that if you use, will get you to the answer. And that's kind of our goal here. We want to factor this thing. So we've done the step 2. We found the number game answer. Step 3 says write the preliminary form of two binomials with x's where you've put these numbers in, -4 and -15. However, again, not the final answer. In fact, I normally won't even put parentheses around them beyond this example. So I don't like it being confusing. But this is the idea. You've got these two forms. Get the preliminary form written, then divide P and Q by A. So A meaning this number, whatever the lead term was, 6. So we've got this form, but now I'm going to put each of those numbers, both P and Q, over 6 and write the fraction in lowest terms. Okay, so this 4/6 would reduce to a 2/3. This 15/6 would reduce to a 5/2. Right, reduce those both by 2, those both by 3. it's very important that you reduce them as much as possible, okay? Because it says if there's a denominator not equal to 1, bring the denominator up to become the coefficient of x. So here's a fraction. The denominator is not 1. The reason this method is called the bottoms-up method or bottoms-up approach is the bottom, the denominator, gets brought up in front of that x term. With this fraction, again, the denominator is not 1. The bottom gets brought up. 3 in front of the x makes that 3x, and we've got the minus 2 sitting there after it. 2 being brought up makes that 2x with the minus 5 sitting there after it. And that right there is actually the factored form of that polynomial, that trinomial. So again, this part of the process here, mathematically, algebraically, makes no sense for us to just decide we want to divide something by 6 and definitely just bringing up denominators because we want to. None of that mathematically by itself makes any sense. But it's a set of steps that we know that if we follow, will always get us to this form right here, which will be the correct factored form. Okay? So we're going to see more examples of it because this is a process you got to practice to get used to those steps because they kind of come out of nowhere. If you don't know them, it doesn't make sense to do them. So you got to practice this a lot. But let's take a look at the next example. So we see x squared x no x. We see something other than a 1, so not an easy case. We're going to start with the GCF to make sure that doesn't help us. But 10, 17, and 3, GCF is 1, doesn't help us. All right, so now that we know we're in the bottoms-up approach, because of this not being a 1, we start with the a times c, the 10 times 3, giving me 30. So I need factors of 30. 1 and 30, 2 and 15, 3 and 10, 4 and nothing, and 5 and 6, and we're done. Of those factors, or those pairs, we're looking for the pair that multiply to a positive 30 and add to a positive 17, which would be a positive 2 and 15. So we take our 2 and our 15, and I'll come over here. And like I said, I'm not going to really even put them in parentheses because I don't want that to be, confusing. I don't want you to think you're in a form where that's your answer. This is just a step, preliminary form. Once you've got that form, we will take the a value, always this first term, and divide both those terms by it, both those numbers, reducing it down to x plus 1/5 and x plus 3/2. Now, with the denominators getting brought up, the bottoms up, the 5 sits in front of the x with a plus 1 after it, and a 2x plus 3, and done. Another thing I will say about this bottoms-up method, this is a great place to take the time to check your answer because you're doing a lot of weird things in here that, again, you just have to make sure you know how to do and do correctly, and there's no really easy way to catch whether you did something wrong. The way to catch it is right here. If you draw those 4 arcs, you got to get back to your original trinomial. So this is a great place to take the time to check your answers. All right, let's take a look at a couple more here, actually several more. All right, so see r squared r no r. We see something other than a 1 out front. Let's see if the first step GCF helps us. It does not. So we're stuck with this. So we're stuck with bottoms up. So 6 times, and make sure you get the signs right here. That'll be a -5, so that'll be a -30. Number-wise, it's still the same factors, 2 and 15, 3 and 10, 5 and 6. But keeping in mind, this is a -30. Right? This is another one that can be tricky, because if you're looking for 2 numbers to give you a 13, 2 and 15 look like they might be able to get you 13, but so do 3 and 10, right? They both seem possible. Keep in mind, if you're multiplying to a -30, you've got to have opposite signs. And the only pair with opposite signs to give you a positive 13 would be a -2 and a positive 15. The 3 and the 10 actually do not work. So there's our 2 numbers, -2 and positive 15. So x minus 2, x plus 15. We take those 2 numbers over here. We then use our a to create the fractions, which reduces to x minus 1/3 and x minus 5/2. And then any bottoms come up to 3x minus 1 and 2x plus 5. Like I said, the more often you do this process, you get to just recalling what it makes sense to do, what you're supposed to do with the steps to get from this number game through to those answers. But it does take practice. All right, number 4. Notice we do have an m squared m no m and an n squared n no n pattern. And if we see if the GCF changes anything, it does not. GCF is 1. So now we will start this process the same as the other ones because, like we said, this is a special pattern that still fits this method, just like the easy case number game did as well. So we start with the A and the C. Another 6 times negative 5, giving me a negative 30. So same pairs of numbers for factors of 30. And now I want them to add to a positive 7. Well, negative meaning opposite sign, but adding to a positive 7 looks like it'll be negative 3 and positive 10. Now, I do want to make sure I use the right variable. As I just noticed, I actually used the wrong variable up here. Let's go back up here. I apologize for this. We were dealing with the variable r, so every one of these x's that we drew definitely should have been r's. That is my bad. I apologize. That should be r's for both those variables. Very important to make sure we use the correct variable from the problems. So back down to here, as I was just about to write an x, notice the pattern we're actually following is with m's. So we're going to need this to be an m minus 3 and an m plus 10. I would say you can put the n's. We know the n's will be there. You can put them now. You can put them later. That's up to you. I'm going to just focus on the number game part and the bottoms up part, and then recall the n's at the end, kind of like we did with the easy case number game too. So the 3 and the 10 both get divided by the 6, reducing to an m minus 1/2 and an m plus 5/3. And then the bottom's coming up, giving me 2m minus 1. I'll just go ahead and do this here, and a 3m plus 5. But for our final answer, needing to make sure we get that n squared n no n pattern going backwards, we definitely need to get the n as the variable on those second terms there. So 2m minus n, or 2 minus 1n, 3m plus 5n is the factored form for that polynomial. All right, and 2 more examples here for us. We see a p squared p no p. We see a number out front. We look at the GCF and notice that negative is a very annoying issue that we want to get rid of. So although the terms have nothing else in common, we will say a GCF here exists of negative 1. Factoring out that negative does nothing more than changes every sign. So we're looking at that. So keep in mind now, this negative has been factored out, and this is now the polynomial you are working with. This will be the thing we do the bottoms up on. So just ignore that thing up there. So going over to the bottoms up approach, we need 2 times negative 12. So negative 24. We need factors of negative 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. But we want the factors that multiply to a negative 24 and add to this positive 5. So negative 3 and positive 8. So over here, using the correct variable, I'll forget the negative for the moment as we're focusing on the bottoms up approach. So p with a minus 3 and p with a plus 8. Now, those two get divided by this a right here, divided by a 2. That doesn't reduce at all, just p minus 3/2. This reduces down to a 4, right? P plus 4. So with the bottoms up, it's important to remember that it mentioned that if a denominator is not 1, you bring it up, but there's no bottom here. So this 2 coming out front, giving us 2p minus 3. However, this factor here will just be the factor p plus 4. And then the negative that we factored out at the very beginning of the problem is a part of this polynomial. I'll bring it down set it out front, and we have our factored form. And our last example here, notice the pattern, m cubed m squared m. That's showing you we definitely have something going on in terms of a GCF. So let's see what we got. With the numbers 4, 2, and 6, there's even a 2 in common, and that m. So factoring out the 2m as a GCF will leave us with 2m squared plus an m minus 3, right? So that's factored out. And again, just ignore it, forget it's there while we work with this. With a 2 out front, this will be a bottoms-up approach. So 2 times -3, giving me a -6. So the only factors of 6 are 1 and 6 and 2 and 3. I want them to multiply to a -6, but add to a +1. So -2 and a +3 will be what I want. My variable here is m, so m minus 2, m plus 3. Those are my numbers from the number game, but divide them by this a, whatever was left over after the GCF. Those will reduce completely down to a -1. That will not reduce at all. So no bottom here, just this denominator to come up right there. So we'll have the factor of m minus 1, and another factor of 2m plus 3, and we will make sure and not forget the GCF from the beginning of the problem that is part of the polynomial. Come down in front, and there's our factored form.